and welcome to another episode of the FDM-printed SLA-printer. This time we built this thing. But first let's have a look on the parts that we need. We need a 3D printed part polycore STL, a NEMA 70 stepper motor, and shaft coupler 8mm to 5mm, an 8mm lead screw, an LED constant current driver, an nano-DLB shield, and Raspberry Pi Model 3, a micro switch with some wire soldered, and tactile switch on a PCB soldered, and 6002 I2C LCD display, a 5.5 inch HDMI LCD display and LCD controller, a 19mm power switch, and parallel connector, and 5mm red LED, a bunch of M3 by 10mm screws and two M5 by 50mm screws. So let's get started. Basically all these electronic components go into the what I call the core part. And it's recommended to start with those elements that appear on the front panel, because for one simple reason they all need to get screwed in horizontally, and this is much more easier when the components in the back are not yet installed. The first component that we install is the 6002 I2C LCD display, which should fit quite well in the corresponding hole of the 3D printed part. The PCB has 4 screw holes that match with the corresponding screw holes of the 3D printed part, and I'm quite confident that 2 screws will do the job when they screwed in over diagonal. The next front panel element that we install is the stop shutdown switch, which requires first a tiny 3D printed part that looks like this. Can be found on the file section of the Thingiverse thing. It looks exactly like a knob look like. Due to the very specific shape of the base of this knob, it's very easy to align it properly to the corresponding hole in the core component. Just put it in place like this. Once it's there, the next piece is the PCB that carries the tactile switch. It should be soldered in a way that the tactile switch is centered to the knob. In addition, the PCB should have 4 screw holes that match with the corresponding screw holes of the core component, so that the tactile switch board can be installed. Again, 2 screws should do the job. Just make sure that you don't over tighten those screws. Check that the tactile switch still clicks when you press on the button. If you hear no click, it's over tight and you have to loosen the screws. Next we add some wires to the 6002 I2C LCD display. It's in 4 leads flat ribbon cable, and it has 2 female type pinhead connectors on each side. The 3D printed core component has a couple of geometric elements that should help to organize the wiring. One of them is this post where we put the wire behind. Similar to the post in the front, there are a couple of holes in the back of the geometry of the core component that helps us organizing the wiring by pulling through the wires and their connectors, just to make sure that once the assembly is done, the wires will not free floating. The red 5mm LED is pretty simple to install. It's just a push fit in the corresponding hole in the core component in the front panel. Again, we use the geometry of the core component to organize the wiring of the red 5mm LED. push button in the front panel will be wired just in the same way. On the right side of the core component there's a small channel to guide the wire of the push button to the back. A small piece of double-sided adhesive tape will be used to keep it in place. We keep the protection sheet of the double-sided adhesive tape for the moment where it is and come back to it a little bit later. Now it's time to install the 90mm power switch to the backside of the core component. Just push it in the corresponding opening until you hear a clicking noise. A pair of pliers can be used to adjust the orientation of the switch. Then we apply the wire harness for the power supply to the power switch. This wire harness interconnects the barrel connector where the 12-volt power supply comes in with the power switch and finally with the control board. The micro switch for the Z and stop on the bottom of the Z axis will be installed next. This will be applied from the top side of the core component. Now it's time to get the Raspberry Pi installed. Just align the 4 screw holes in the PCB of the Raspberry Pi with the 4 screw holes of the 4 posts in the core component. Also align the USB ports and the Ethernet port in the back of the Raspberry Pi with the back of the core component. Use 4 of the M3 by 10mm screws to fixate the Raspberry Pi on the corresponding posts. Then the nano DLB shield will be installed with the 40-pin pinhead connector on the top of the Raspberry Pi's G/O port. The 2 open ends of the power supply's wire harness will be put into the screw terminal of the nano DLB's 12-volt input. Make absolutely sure not to confuse the voltage line and the ground line. In any case of doubt, refer to the graphic for the nano DLB shield. Then we install the LED constant current driver on the corresponding posts. The 12-volt input line of the constant current LED driver will be connected with the shutter-controlled 12-volt output of the nano DLB shield. Again, be aware of the polarity of the wires, don't confuse voltage and ground. The barrel connector for the power supply will be installed in the corresponding hole in the back side of the core component. As barrel connectors come with a specific nut that will be used to fixate the barrel connector from outside of the case. Now it's a good time to connect all the wires that we already have installed to the NanoDLB shield. For the right connectors and the right orientation of the connectors, just refer to the diagram of the NanoDLB shield. Next item on the list is the UV reflector, which consists of a 3D printed part and a couple of mirror tiles that glued inside. The 3D printed part of the UV reflector can be found on the Thingiverse page. Just go there to the overview of the STL files, and it can be easily identified as a kind of three-dimensional frame. The installation of the UV reflector can indeed be a little bit tricky, as we already have a couple of components installed. So it might become necessary to loosen the NanoDLB shield first to get the reflector better in place. But nevertheless, it should be possible. Once the reflector is in place, it has to be secured by the use of 4 M3 by 10mm screws. In case you had to remove the NanoDLB shield, don't forget to reapply it. The display controller for the 5.5-inch display will be installed next. The core component has some slots where the controller just slides in. Again, we use the post near to the front panel to organize the wire, especially the flat ribbon cable that goes from the controller to the display. Also, we use a piece of double-sided adhesive tape to keep the display controller in place. Now it's a good time to screw in the two M5 by 50mm screws. Later, during the print operation, those screws will be used to keep the VAT in place. And again it's time for some wiring. We have a special kind of HDMI cable that comes with a flat ribbon cable in the middle and two tiny HDMI connectors that are angled by 90 degrees. The display controller and the display are powered by 5 volt that will be supplied by a micro USB cable. Just pitch a standard micro USB cable by cutting off the one end and apply the 5 volts and ground cable to a pinhead connector to get it connected to the nano DLP port. Now we install the NEMA 70 stepper motor together with the shaft coupler and the 8mm lead screw. And yes, of course you are right, it would be much easier to install the 3 parts separately. But unfortunately, most likely because I assembled and disassembled too many versions of this, the 8mm screw gets stuck into the shaft coupler and it's almost impossible to separate them. And again, the NEMA 17 will be secured in place by the use of 4 and 3 by 10mm screws, my favorite type of screw. Finally, the 5.5 inch display gets installed. This should be prepared by removing the backlight and also by applying the protective glass on top of it. The flat ribbon cable of the display has to be pushed through a slit that has to be cut into the right side of the UV reflector. Those thumbs nuts can be used to keep the display temporarily in place. Alternatively, we can use double-sided adhesive tape to fixate the display to the frame of the reflector. Before I connect the flat ribbon cable of the display with the flat ribbon cable of the controller, I have to remove some remains of a previous installation. The display's flat ribbon cable has a connector that just gets push fit on top of the PCB that is connected to the flat ribbon cable of the controller. The tiny piece of double-sided adhesive tape that we applied at the beginning will now come in handy to fixate these connector PCB. As I had to remove the HDMI cable to better install the NEMA 70 stepper motor, I now have to reapply it. The electronics of the UV light unit, which is installed in the outer shell, can now be connected with the nano DLP port. The first piece of electronic is a 12-volt fan, which is a very important part of the UV light's heatsink. And yes, better double check that you have the polarity right, don't confuse the voltage line with the ground line. The second piece of electronic from the UV light unit are UV LEDs themselves. Most UV LEDs should run on 12 volts and need to get connected to the LED constant current driver. We intend to have a second Z and stop switch which shall reside in the top piece of the Z-axis. Therefore we install one more 2-lead flat ribbon cable before we enclose the core component inside the outer shell. Dark side in context of resin printing basically means smelly side, messy side. In case you already had the pleasure, I'm pretty sure you know what I mean. Well, in the meantime we already started assembling the Z slider by applying the lead screw nut. The two linear bearings of the type LM8LUU will just be applied by push fit. The two 4mm thumb screws will serve as adjustable trigger points for the Z end stops. Time to apply the aluminium rods and bars. First we need to feed the wire that we prepared for the second Z end stop through one of the bars. Then this bar and all the other bars and rods will be applied to the corresponding holes in the core component. The prepared Z slider will go on top of the both rods and the 8mm lead screw. A ball bearing with an inner diameter of 8mm and outer diameter of 22mm will go on top of the 8mm lead screw. When installing the Z-axis top piece, we need to feed again the wires for the Z end stop through the corresponding hole in the component. A micro switch for the second Z-axis end stop will be applied to the Z-axis top piece. To prevent it from falling out, we can either apply a drop of hot glue or alternatively wrap around a couple of layers of Scotch tape. Once installed, we join the connector of the micro switch with the connector of the wire, and finally hide the connectors and the wires in the grooves that are prepared in the top piece. Time for a first test. Let's apply the plug for the power supply and the Ethernet cable. Let's switch the machine on and see if there will be smoke. No, the SAT lights up. After a couple of seconds, NanoDLB shows the TCP/IP address that the network assigns to the machine. Also, NanoDLB starts moving the stepper motor for going to the install position. Time for some more testing. Let's see if the UV light works and out of the main display. While it basically works, I discovered that I have to add some diffuser for the UV light to reduce these bright spots that are obvious on this video footage. And now for some test of the Z-axis movement. Okay, that's it for today. I hope you enjoyed this episode and found it interesting. Hope to see you next time, maybe to another episode of the FDM-printed SLA printer.